Hi, this is a screencast tutorial for using the Python library for interacting with the TESS Focal Plane Electronics hardware stack. That includes Jim Littlefield's observatory simulator box, Carrie's FPGA, and John Doty's focal plane electronics. And so I know that a lot of people are interested in using this software, so I thought I would give a tutorial for how to install it and then how to interact with the device using this software. So I'll start by installing. So you go to Test Science, tessfpe, and you look at this URL here, https github.com, test science, tessfpe.git, and we'll go ahead and we'll install that software by doing git clone followed by that URL that we copied. And then if you want to go and install the software, you do make -c tessfpe test suite install, and then it will go ahead and it will install NumPy and SciPy and Pandas and some other Python modules that I use. I already did that over here, so we can just go ahead and use the software without having to wait for all that installation. So the way that you would use the software is you'd type source test suite vm bin activate. And if you're using, this is if you're using bash. If you're using T shell, then you'll have to use a different command, but you can see the commands to type by going to the wiki, CLI tessfp documentation, and then I go over this installation and then how to set up the shell. And now that we've set up the shell, I want to go and show you how you'd bring up the observatory simulator. So I have a command that I use for interacting with a hardware reset switch. This is provided by a different company that isn't part of the tessfpe hardware stack, but it's convenient anyway for my purposes. So you can so this switch command lets you if you just type switch, then it will let you. It'll ask you to. It'll ask you to log in if you haven't already logged in, and then it will just tell you the status of all of the hardware switches. So if you do switch --reset obsim, it will go ahead and reset the switch that is labeled obsim. And so now that is effectively turning the stack off and then turning it back on. Now that we've turned it off and we've turned it back on, we should load a wrapper for Carrie's FPGA. And so we'll use this command load wrapper --help tells us how to use it. We need to specify a wrapper version. So there's here are the ones that are supported. So the one that I know that works on this particular box is 6.1t.4. And you can type load wrapper 6.1t.4, and that will go ahead and it runs a FPGA reset command, which resets the power line on the FPGA. It then loads the wrapper as well as housekeeping memory and registry memory and sets the operating parameters to their default values. Finally, it checks the housekeeping to look to see if there is if certain reference voltages are the values that they are supposed to be. And we can do that too. We don't by just typing the housekeeping command, and then looking at the first few lines it prints out are in fact the reference voltages. So we can do this, see, and so we can see that uh, the 1.8 reference voltage is around 0.02 volts from its expected value, as well as the 15 volt line, the 1 volt line. There's two 3.3. One of them isn't checked yet, um, and so because all of these are within their well within their expected range, we infer that the um, the wrapper has indeed been uploaded to Carrie's FPGA, and that it is communicating properly with the focal plane electronics. If you want to gather uh, if you want to gather more than just one sample of housekeeping, for instance, if you want to gather some statistics, I offer a samples command you can do. So you can do housekeeping minus samples and then 20. Um, and it will gather 20 samples of housekeeping. And print the average measured, as well as the standard deviation as compared to the expected value. So you might also want to look at the digital housekeeping. This is data that Carrie's FPGA provides for some of its internal registers. Now, you can also look at the what the operating parameters, or sometimes called clock voltages, are set to by typing the operating parameters command, and that will read the operating parameters and parse them and tell you what it thinks these values are. These are all set to the default values from the data sheet that John Doty provides. They can, but if you want, you can set them to a different value. The way that you set them is you just say operating parameters, and then you give it a file that's called a JSON. So we'll have, here's one that sets everything to their low values, and as you can see, everything's kind of zeroed out and at their minimal values. But if you want to restore the defaults, well, you can see there's a set defaults command, and then that restores the defaults. Now, if you don't want to set all of them at once, like in that file, you can set a particular one. So you might want to. So if you want to set a particular value, you can, for instance, say set the CCD4 scupper to 0, and that zeroes out the scupper and leaves all the other values as they are. So another command that might be of interest is you can actually see all of them here in the scripts directory. Another one that is helpful is the upload FPE program. And so this uploads an FPE program written in the DSL for specifying sequences and programs to run. So we can look at an example here. There's program.fpe, and as you can see, it sets default values for all of these bits. It sets a pick cycle sequence, an FR2 serial sequence, and then has some logic. Well, sets some parameters and has some logic for running the various sequences based on the parameters set. And so the upload FPE program command compiles this into two files, a program memory file and a sequence memory file, and uploads them. to the uh, to the to carries FPGA, um, and that's pretty straightforward. Um, it does a lot of stuff, sort of behind your back, making by compiling that code up there into these binary files. Finally, the last thing that might, if you don't, oh yeah, if you want to compile those files without uploading them, you can run uh, the compile fp programs command, and that will compile just the programs. And so you can say like uh, programs.bin. You have to specify which file you want to output to, and then alternately, if you want to specify the sequences, so you would do, instead of compile fp programs, you would do compile fp sequences, and then that would compile the sequences. Similarly, you can do, if you don't want to use the observatory or the operating parameter script to talk to the stack, and you just want to compile what we call a clock voltage file, you can do compile operating parameters and then give it a JSON. So uh, low params.json, that will and then we do, and then actually if you don't specify anything, it'll just come up with a random file. So you don't actually have to say where you're putting it. It'll just like make a random one. Um, all right. And so finally, the last two things I want to go over are the stop frames command and the start frames command. So the start frames command starts the frames, and the stop frames command stops the frames. When you stop the frames, you also have to do a camera reset and re-upload some register memory, but I do that automatically, and then I check to make sure housekeeping is sane. And then once you're done, you can just go check housekeeping, and it should be all within reasonable values of what they are supposed to be. Although those PT sensors all seem to have wildly unexpected values. This, well, and so that's there's still some work to be done on this stack, but I hope that shows how to use the software, and I'll be looking forward to any more questions. Thank you very much.